webinar today, the human eye versus the spectral instrument. My name is Jim Luttrell, Socios Digital Marketing. I'll be your moderator, and it gives me great pleasure to introduce to you Dan Uris, who's the Chief Technology Officer of MeasureColor. Dan, welcome to the webinar.
Thanks, Jim.
Dan is, as I said, the Chief Technology Officer at MeasureColor, and he's been selling and supporting their line of press room process control solutions. And together with his partners, they've developed an install base of over 1,400 active users in countries around the world. And in addition to their software, he also offers color measurement hardware as a value-added reseller for X-Rite, Teshcon, and Rutherford Graphic products. And supplementing the MeasureColor software and measurement instrumentation, Dan also conducts color consulting and theory training to printers worldwide. So he's uniquely qualified to speak to us on this theme today. Before I introduce Dan to speak to you, just a quick bit of housekeeping. If you have any questions during this presentation, feel free to use the panel on your webinar drop-down, and you can submit any questions that you may have, and we'll be happy to consider them in the Q&A. So Dan, without any further ado, we're happy to listen to you.
Thanks again, Jim, and welcome everyone to the presentation. Hope everyone's having a great Friday, and look forward to talking to you about this presentation we have called the human eye versus the spectral instrument. Now, before I begin, let's talk about why we have this conversation. Sorry to subject you to this one more time. You've probably seen it a lot already, but it illustrates a great point, and that, of course, is the dress. The dress is something that maybe you have seen on social media lately. It was quite a buzz a few weeks ago when it originally came out. Some people saw black and blue. Some people saw white and gold. Everybody was looking at pretty much the same picture, and yet so many different people were swearing by seeing different things. So this is just a fantastic illustration and opportunity to talk about why we need to be very considerate of the human eye when we use it to visually evaluate color. So keeping this in mind, and keeping in mind how much, I don't know if you would call it controversy or discussion came up as people would argue, you'd have your white and gold camp, your blue and black camp, and it got very heated online. So let's talk about why that may have been. We'll begin the presentation by talking about what is the best tool. This is always a question I ask when I begin my color theory presentations, and there's no right or wrong answer, but let me put it to you, and although you're in mute mode right now, please consider to yourself which you believe to be the better tool. Is it your human eye, or is it the instrument that you've elected to use? Now, certainly both of these things are tools. Each of them have benefits and risks. And what we're going to do a little bit later as we go along the presentation is talk about what these are and how we can overcome these risks to achieve the benefits capable of each. Next, we'll talk about what kind of steps you can take to build trust in both. Certainly, you want to be able to trust your eye, you want to be able to trust your instrument, and there are certain ways that you can do to make you have a higher confidence in your usage of each. Now, both of these tools give you a lot of information. The eye can see a lot of information at one time. The instrument sees a very specific area, but gives a lot of scientific information. So what we also aim to do is give you tools to make color measurement easier. So we'll also introduce that. Now, ultimately, at the end of the day, everybody cares about saving money and reducing make-ready time. So we'll introduce how the best use of your eye and the best use of the instrument can help you with these objectives as well. So let's begin with the eye factor. I want to start by introducing some potential issues using your eye to evaluate color. The first is called retinal fatigue. The eye, just like any other muscle in your body, gets tired the more you use it. So if you're looking at the same piece of material over a long amount of time, your eye becomes actually accustomed to looking at that material. There is actually a chemical reaction that occurs in your eye as your eye becomes conditioned to whatever it is you're looking at. And the longer you look at that same thing, your eye loses its capability to perceive color change. Next is what we call area effects. Area effects are when surrounding colors influence the color we're trying to evaluate, control, or measure. Our eye sees a lot of color at a time when it's looking at something, and it's very difficult to selectively eliminate or focus just on one area of something we're trying to control. We may have a brand blue in the center of a design, but it's surrounded by an orange color on the rest of the box or the carton or the sheet, whatever it may be. And while we're only focusing or trying to work on that blue, that surrounding orange or whatever color it may be plays a big role in our evaluation of the blue. Next, color memory. People like to think they have a good capability of looking at something, remembering what it is, and then looking at something else and telling themselves or someone else if it's the same or different. Truth of the matter is, color memory is something that we all honestly really struggle with. As quickly as it may be that we look at whatever the target is compared to the sample, our ability to remember in our mind what a color actually looks like is extremely difficult. Color blindness is also an important thing to consider when using the eye because many people suffer from some degree of color blindness. There was a study that was conducted that found approximately 1 in 12 men has some degree of color blindness, while the same statistic for women, 1 in 300. So something to certainly be considerate of when you're looking at color, when you're comparing if color blindness is something that could be affecting your perception. Now, thankfully, color vision tests are readily available both online in physical form as well as from a doctor's office or a testing facility. So it's very easy to find out if some degree of color blindness is influencing your vision. And like many other things, once you know about it, you can then work around it. So certainly color blindness I've never heard of being a disqualifying offense for working in a printer or being a printer. It's something you just need to know how to work around. Next, sample illumination method, a fancy way of saying how we light the material that we look at. We need to be very considerate of the lighting environment because the type of light plays an enormous role on our visual perception of what we're looking at. You could take the same carton, bottle, box, whatever it may be, and look at it both outside, inside under fluorescent light, at home under incandescent light, and in those three different environments, incandescent, fluorescent, and daylight, that same material, that same ink can take on three totally different appearances subject to something that we call metamerism. So using controlled lighting, being conscious of the light you're using to evaluate your material can play a big effect on how you visually perceive if that color is accurate or not. Now, as if these weren't enough, your stress level can also play a role. If you have a customer on site for an on-press approval, if you've had a machine down all day for a maintenance problem, all of these things end up increasing your stress level and making your mind actually want to see the proper color faster such that you can produce the job and move along. Problem is that when we start seeing color that we want to be correct and we start thinking it's correct, maybe our spectrophotometer is telling us that it's not correct, but we think that it is, we can actually convince ourselves in our mind because of the amount of stress that we're under that that color is good enough and that it can make it and you should move on. The biggest problem we see in the industry today is customers or print buyers are starting to purchase their own spectrophotometer devices. So they're checking the work that's coming in. Some customers are even insisting that the spectral measurements are taken before the material even ships. So the customers are oftentimes looking at that pure numerical data regardless of what it visually looks like, and they're saying if it doesn't match our target, then you don't have the right to ship it or we're going to reject it. So certainly there's much more to consider than just the numbers, but a lot of times we see customers now making buying decisions based upon that. So it's very important to be conscious of our stress level and make sure that's not influencing our perception. This next slide shows 6 different examples of presentations or components of presentations that demonstrate each one of these effects that I've just talked about. Each one of these is unique in what it does. They're usually part of a color theory presentation that we give if we're hired to come on site and discuss with operators the correct way to do color measurement. But we have a lot of great examples of how you can actually prove to someone that the eye is not always the best tool to make your color evaluation. There are a lot of ways that it's challenged and a lot of weaknesses that need to be considered, or else you could have significant problems if your eye were your only tool in color measurement. Now let's talk about the instrument. While the instrument is a fantastic tool, it is that. It is a tool. It must be used in a certain way. And I want to talk about first some of the potential issues with using an instrument to evaluate color. Number one, and probably the most important one, is the instrument type. Hopefully, many of you on the call will know the difference between these two types of instrumentation, but oftentimes as I give the presentation, I find that there's some explanation desired. A lot of print shops will have densitometers, which are density measuring devices or instruments that emit light, measure the reflectance, and from that calculate an ink film thickness. Now, what this is a measurement of amount of ink that's on a particular substrate. So it's the amount of ink that you're putting down. But oftentimes you may put down the same amount of ink but have a different color. A classic example would be cyan and magenta. Both can frequently be printed at a density of 145, but nobody would agree that those are the same color, but they are running at the same density. Now, the other type of instrument is called a spectrophotometer. A spectrophotometer is the first type of instrument that can measure color. So it actually divides the color into many different segments, and then from there can accurately measure what a sample looks like. And if it has a standard loaded into the instrument or there's a piece of software helping you, it can make a color comparison and tell you if the color is what you want it to be or not. So that's a very important thing if deciding, is this tool going to help you, is knowing if it's just a tool for measuring density or the amount of ink down, or is it a tool that can actually measure the color and qualify if the color is correct. Next, let's talk about the make and the model. There are a few different device manufacturers today. Some of them use different types of technology in their optical design. Some devices use a filter system that passes light reflectance back through a number of filters and takes its measurement that way. There are other devices that use a system called diffraction grating, which passes light through a prism and then takes measurements across the spectrum through the prism to get its measurement. Both are perfectly good systems, but it's important to know which one you're using. It is possible if you use some systems that are or instruments that are filter-based and others that are diffraction-based, that while both are very reliable, they may measure differently consistently. So you may see that both one is consistently one way, the other is consistently another, even though to themselves they're very similar and very consistent. Because of the type of technology they use, it can produce slightly different results. So my best recommendation is for your color measurement, make sure your devices use the same type of technology, be it filter-based or diffraction-based. Next to consider is the aperture size. The aperture size is the measurement area. It's that spot in the center of your aperture that is actually going to be observed for color. Now, as your aperture size gets larger, typically your readings are more reliable and more consistent. However, everyone today is trying to use the smallest patches possible to get color bars into areas where maybe they couldn't fit before, or maybe trying to keep the most minimal amount of waste possible by saving area with smaller control marks. Instruments today can go down to an aperture size of about 1.5 millimeters, which is very convenient for getting into a smaller patch. But what you need to know when using that size aperture is that opens up the opportunity for more variance in the measurement. The instrument has less reflectance to work with at that size, and you may see more variation in the measurement when using a smaller aperture size. Instruments today also have the capability of carrying extra filters or extra ways of changing the reflectance to meet certain needs, and the two most popular are polarization or UV cut. I don't want to go too far into the technical details of why you would use each of these right now, but it is important that if your instrument carries either one of these filters that you know that it's there, that you know if it's enabled or disabled, if it is switchable, or that you know that if you have an instrument that has a fixed filter like one of these, that it's not being compared to an instrument without. We must maintain a level playing field when using our instrumentation to make sure that we get consistent measurements that are safe to compare. Now, these instruments are very complicated devices. They do a lot of measurement internally. There's a lot of science behind how they come up with their result, and therefore there are a lot of settings that need to be managed. Two of the most common are the density status and the illuminant and observer angle. Density status, typically in the United States, North America, we use density status T, while in Europe they use status E. Again, nothing wrong with either of these settings. It's a little bit of a different way of looking at color for density or looking at ink for density, but it's important that we make sure all of our instruments are set the same way, and that if we're asked to match something from someone else, that they're using the same settings themselves that they're asking you to measure against and that your instruments are set up for. Illuminant and observer angle, this is the control inside the instrument for what type of light it's going to compare against the reflectance back into the instrument. Observer angle is the same. You can either have a 2 or 10 degree setting to correlate with the way the original spectrophotometer is measured, or closer to the way the human eye sees color. But again, these are more settings that we want to make sure we have standardized and set appropriately across all of our instruments. Calibration is a critical factor. You must make sure your instrument is daily calibrated, and that's only a valid step if your calibration plaque is clean. So it's very important to monitor the calibration plaque condition, make sure that it is as clean as possible, that there is no dirt, smudges, and you should also follow your instrument manufacturer's guidelines for the proper cleaning technique of that calibration plaque. Each manufacturer will have their own suggestions for the proper upkeep to maintain proper measurement. Lastly, the last factory calibration or certification date is something that you should consider. Typically, this is known by a little sticker on the bottom of the instrument that states the last time it was in for service or in for certification from the manufacturer. And usually, depending on your ISO settings, or your ISO policies or procedures, you'll have to calibrate or certify your instrument either once every 12 or 24 months, depending on what you've set up your ISO certification program upon. So it's important that if you do have to do it every 12 or 24 months, that you're following that procedure and that you're ensuring your device is always certified from the manufacturer, ensuring that as it ages, it's consistently returning the results you expect. So next, let's talk about the benefits and risks of each. The eye, it's what the consumer uses. It's a common tool for all operators, so it's very handy to have a tool that everybody has. You don't have to worry about which press it's on. Everybody has the eye, and it's what we're most familiar with. So it's a very strong benefit to using the eye. There's more visibility of your complete image when you're using the eye, where the spectrophotometer is going to look just at one small area. So where the eye can evaluate many different things, the visual quality of the print, how process inks are being built together, that's a very good benefit of being able to gather all that information very quickly and see what's going on. The eye can also be qualified and tested for its color perception, so that you know if the eye has any deficiencies that you need to be concerned with, or if you have pretty good color vision. The eye is very fast and easy to use. No operational knowledge is necessary to use it. You simply look at something and very quickly you say, yes, that's good or bad. The eye is also unique in that we as humans have a perception to what we see. That perception is also linked to emotion, and that can give us a feeling as to what it is that we're looking at. So, you can see something that's very strong and vibrant and saturated, looks very pretty, and that really can convey more than just the color, but it's the color, it's the image, and all of that. You can say, wow, that is a beautiful picture, where the instrument is just going to say, here's some densities or LAB numbers. Now, with these benefits, there are also some risks that we want to consider. The risks that the eye is open to is, number one, subjectivity and gender. So each of us will see color in a slightly different way. This is something that it's very easy to demonstrate with something like the dress. That's a great example of subjectivity, as well as gender. You heard me talk about in color blindness that different eyes from different genders have either more or less susceptibility to a color blindness issue. Now, the eye is also at risk from the environment and the lighting that it's used upon. A lot of people can't deploy color-controlled light booths everywhere. Maybe the press room has one or two. Oftentimes, there's not color-controlled lighting at each press. And then you have the mixture of console illumination with ceiling and ambient illumination. Now, all of these things can affect and will be factored in when our eye visually appraises a printed sheet or a color match. So it is very risky to be considerate of which environment you're looking at and what can be influencing your vision. Now, much like the light changes over time as you age, your eye actually changes. The lenses of your eyes, they harden. They actually change color. They go more yellow. So we need to be concerned with, as we get older, whether our color vision is changing as the nature of our eyes change. Thankfully, again, this is something that we can test for and be qualified for, so we can monitor this over time and find out when it's starting to become an effect. Now, the eye also has the risk of the field of view. The eye sees a lot of information at a time, and it gathers a lot of reflectance at one time. So back to my example of that carton with a blue brand name and an orange background, that orange background is going to affect the way we perceive the blue, no matter what techniques we try to feel that out of our vision. So it's always going to play a role. Now, the spectrophotometer has a very small aperture that usually you can fit into all necessary areas and make sure that you're only including in your measurement the color that you're trying to control. The eye is also susceptible to risks of lenses, glasses, and coatings that you put in front of it, be it colored contact lenses, colored glasses, coatings on glasses to protect against scratches or reflectance, coatings on safety glasses or goggles. All of these things can have an influence on the color that passes through them and the color that we perceive. The last problem with the eye is our own reliance and trust upon it. You know, we like to believe what we see as people. We say, well, I see something there and I don't see it as a good color match. I trust my eye. So even though this instrument tells me it's a bad color match, well, I trust my eye. It looks like, you know, it's either failing or passing, and I'm going to accept it or, you know, reject it based upon that. So our own built-in trust and reliance upon our eyes, which we all have, is actually a risk and something we need to be careful upon. Now let's talk about the instrument. Now, what are the benefits of the instrument? Well, number one, it's more commonly becoming what the print buyer uses. They're buying these instruments, they're checking the material, and they're making, you know, purchase or reject decisions based upon what that instrument tells them. Now, the instrument is great because it's objective. Assuming it's well maintained and calibrated daily, it is always going to give back the same measurement. So it's always going to be objective no matter what date and time it's used. So if it's at the beginning of the shift, end of the shift, you know, on a Monday or a Friday, it's going to be objective and tell you the current measurement of that sample. So it's very good for this. It's also very repeatable. The instrument has a much better memory than any person does. So it can digitally store what that color match looks like and very quickly recall it and tell you if what you're measuring is repeatably back to what you want. This also goes into the memory that the instrument has. The instrument also can give you many different types of measurable attributes. Your most capable spectrophotometer today can do all of your densitometric functions: density, dot gain, gray balance, ink trap, print contrast, all of these things, in addition to color measurement, delta E comparison, strip scanning, can do all of these things simultaneously and get all of those attributes for you. Last, the automation of the device is that you can get devices now that scan strips, instruments that are on arms that move themselves amongst the patches they need to collect, instruments for the press room that scan along a track gathering, you know, 600, 800 patches in a given pass. So these are just great ways of gathering a lot more data very quickly. Now, with these benefits also comes some risks we need to be considerate of. Number one is the configuration. You heard me mention that settings are a big important deal. You must maintain that the instruments are set correctly so that they can measure what you want and give you accurate results. It's critical to maintain a proper calibration with the instrument, or else, like any other tool, if it's not calibrated, it will not measure reliably. If the instrument certification is not maintained, so that 12 or 24-month trip back to the manufacturer to be tested and cleaned, without that, again, the instrument can drift and start giving you bad numbers. Now, with the complexity of the instrument and the necessary training operators need to operate them to their full capability, operational error is something that needs to be monitored and tried to be avoided. So with these different settings, with the different operations of the device, we need to make sure that we're using the devices properly, and generally this can be achieved with proper training provided when new instrumentation is rolled out. Now, because these instruments are mechanical devices, some of them are more fragile than others, and if dropped on a hard concrete floor, can be internally damaged. In this case, it may not be readily apparent. Some cases you can have either the optical geometry slightly moved out of position, and that can change the readings, even though the device seems or appears to be measuring properly. So if there is any reason to suspect any kind of damage or mechanical error, it is critical to send that back to the manufacturer for testing and make sure that, again, you can trust the instrument that it is giving you the correct data. Now, the last risk is one that I also talked about when talking about the eye, and that's the reliance or the blind trust sometimes people place in instrumentation. If you're solely going to look at what the instrument tells you, well, then that is going to open up the opportunity that if it is miscalibrated or something is wrong and you're starting to make decisions on that bad data, well, that is absolutely a risk. So just like the eye, the instrument is also a tool. If your eye is telling you one thing that the instrument doesn't agree with, or your instrument is telling you something that the eye doesn't agree with, no matter which way, you should always do some kind of checking. So whether that's getting another person to visually look at it or another instrument to measure it to see if those two measurements line up, it's important, and we can counter those risks to use both tools effectively. So which is the better tool? Is it the eye or is it the instrument? Well, it depends on your objective. For pleasing color, the eye usually can identify, but the instrument is really going to be very helpful to maintain. You heard me talk very early in the presentation about your eye becoming conditioned and losing its perception capability for seeing color change. Well, even if you're just trying to maintain pleasing color, if your eye is actually changing or losing its ability to see color change, well, then pleasing color, getting sheets that match, may be very difficult. So the eye is perfectly useful in these type of environments to identify what that target is going to be, whether it's the customer on site signing off on a sheet or just your own print manager saying this looks good, let's go ahead and run it. That's okay. But the instrument is then going to be your best tool to measure that sheet and then capture what that target is going to look like for the rest of the run and then help you maintain it. Now, if your objective is contract color, the instrument can verify. So the instrument's going to measure that sheet. It's going to tell you numerically, are you inside or outside of your targets? And this is critical for making sure that you're able to run. But the eye is also going to help you evaluate the work as a whole. Again, the instrument is looking at a very small spot at each time, even if it is across many different patches and patch types. But the eye is going to see how it all comes together. The eye is going to see non-measurable attributes. So the eye is very important still for contract color environments for making sure that it works both numerically as measured and visually as it all comes together. So what I'm getting at is that a combination of both are best. Now, this is only good if you exercise proper usage of each, and you must remember that both are tools, both are subject to their own benefits and risks, so we must use proper consideration to obtain the best results. Now, what steps can you do to build trust in both? Let's start with the eye. Number one, absolutely most critical, please use a light booth with proper bulbs when you're going to visually analyze some printed material. Now, you can check that light booth for its proper color output with a device called a spectrometer. This can be as simple as an I1 with an ambient light cap, or as I have illustrated in this picture, this device is called a GL Spectus. It's produced or resold, I should say, by Use Normlic. You can use this device in your light booth to make sure that both your bulbs are functioning properly, you're getting the proper amount of illumination, and that you're getting an evenness of that illumination all the way across the sheet. Additionally, you can use REM indicators to verify D50 lighting conditions. REM indicators are these little stickers that I have on the right side of the slide now, and if you can see stripes in them, the stripes can tell you what type of light condition it is that you're looking at the sheet under. If you see two stripes in the middle, most likely you're looking at it under incandescent light. If you look at the bottom strip where you have three stripes, one on the left, right, and center, that's most likely uncontrolled cool white fluorescent. But if you see no stripes, like in the middle, that's 5000 K light, and that's proper for visual evaluation. You can also take a color vision test with an FM100 hue test. This test is available in a couple different ways. It's available as tiles in a physical chipset, as you see in the lower right-hand corner, or it's available online on the web off of X-Rite's webpage. Here's the website address, and I'll leave this up for a couple moments. The address is www.xrite.com/online-color-test-challenge. And I'll leave that up here for a couple moments so that you can write that down. What you see just to the right of that text is a digital representation of that tile test. So on your computer, you can arrange those tiles in order, and it'll give you a grade as to what it believes your color vision to be. Now, of the reliability of these, I would say the online one, probably has the least reliability because it is subject to the way your monitor displays those colors and the color gamut of your monitor, but it's a good starting point. From there, you can buy the FM100 tile test. That's available for, I believe, around $700, and you can get that and physically measure people inside your company for their color vision. Or you can simply go to a color vision testing facility, be it at your eye doctor or other places I know offer that kind of testing to determine what your color capability is. So finally, submit yourself to color acuity testing to determine if you have any of that color blindness to be aware of. Now let's take a look at the instrument. It's critical to use the correct calibration plaque. You may not have known this, but the calibration plaque that came with your instrument is actually, it's a mass-produced piece of material, so it is tied to the instrument that it comes with at the factory. You should find the serial number of your instrument on the bottom of your calibration plaque, and it's critical to check that serial number and make sure that it matches the instrument that you're using it with, that they are correct. If you were to use the calibration plaque from a different instrument with another one that the serial numbers did not match, you would have grave risk for artificially influencing the results from your instrument because of bad calibration. Now the good news is if you have done this accidentally, it's very easy to fix. You simply recalibrate your instrument to the calibration tile that it came with, and it's back to where it needs to be. Now you absolutely want to ensure that it is clean. If you can observe any dirt on it, usually you can remove that with a lint-free cloth. If you need to use something more than that, some isopropyl alcohol can be used, generally speaking. But just make sure you don't use anything that's abrasive or anything that has a tint in it. So don't use any Windex or any other kind of cleaner that has a colored tint that may reside back on the tile after you clean it. Next, be sure to schedule your annual or biannual certifications from your manufacturer. Again, you'll want to check your ISO requirements to see what you guys are needing to do. But when you get the instrument back, you should have a performance certification on the bottom of it telling you the last time it was measured and approved and when it's due for its next certification. Now, proper and adequate training is available for this instrument operation from the device manufacturers or third parties. So there are many people who can come in or even remotely conduct instrument training and help you get the most out of your investment in the hardware and ensure that you're using it properly. So with all of this, what tools can make your color measurement easier? Well, both the eye and the instrument are very important, as we've demonstrated, but sometimes the eye is unreliable. Sometimes the instrument is too scientific and it's hard to understand. And then even beyond that, frequently reports are needed to verify conformance to your customers or your print buyer. So what can you do? You can use a color measurement software to help. Our software, MeasureColor, is one example, and I want to briefly describe what color measurement software can do for you. Well, any color measurement software can help drive operator focus to critical errors. Color measurement software is going to gather a lot of information, but pretty much all of the packages that are available that are out there will highlight what needs immediate attention. It'll show what's passing versus what's failing, how far it is away from becoming acceptable. Some softwares actually tell you what you can do to help make an improvement, but it's going to bring attention where it's needed. Oftentimes without software, operators may take their instrument, make many measurements across a sheet, but not being able to easily track or recall what those measurements were. Sometimes they have to do them again, and sometimes they're just measuring the wrong color. They may pick one color, measure all the way across a sheet or a sample, and that color may measure fine for all the measurements they make, while at that same moment another color was in critical need of correction, but that correction was delayed because the operator didn't know where to focus first. It's also going to be objective and repeatable. So because it's tied to the instrument, it's going to force the instrument to be calibrated and measuring properly before it displays its results. And again, it's not going to be susceptible to all the problems that a human operator finds, whether it's with the lighting conditions of the area that they're using for measurement, whether it's their their own stress level, day of the week, 10 minutes before they get to go home. The instrument is going to be always measuring objective and repeatably. Another thing it does is it always manages a digital standards library. And this is a really important thing because as we've seen with swatches or tiles or whatever other physical representation of the standard we may be using for our visual comparison, a digital standards library never gets lost. It never gets faded, dirty, never gets replaced and then forgotten to take out of a deck. Whenever that digital standard is properly maintained, it can be shared across all the systems that need to use it. So it ensures everybody is always measuring to the right target and that that target isn't changing over time unless it's intended to be. Now this color measurement software is also going to automate measurement by showing you many different measurements at one time and your accuracy to all the different attributes that you need. So showing all these different attributes and your accuracy to them, again, helps identify where you should be spending your time in making your corrections. It could be that your solid patches for density and color have been right on for a long time, but maybe if you weren't paying as much attention to the dot gain behavior, now maybe that needed some more immediate attention. And color measurement software is great at highlighting that those are the critical areas that you should be working on, while even that the things you primarily inspect are doing well to your targets. Now with all this measurement, it usually is going to trend your historical performance. So you can see from the first sheet to the last sheet, how well was the color maintained, how much variation did the job experience, were there any particular areas that need to go back to be re-inspected, but it's very easy to go back and see in the software, how the whole run performed, and also provide this information to the print buyer to assure them that proper color was maintained for the duration. Now all of this together is going to save time and reduce waste. So these are two things that can very quickly repay any investment in any color measurement software, and they should absolutely be considered in the return on investment that you place in your measurement hardware and software. So all of these attributes combined, why might you want to use the MeasureColor software to do this? The MeasureColor software was designed with three key attributes in mind. The first is what you're seeing here, and that's we want it to be a platform for all different types of measurement. What you're looking at here is a picture of our home screen, and what you see are all the different modules our platform provides, and these different modules facilitate different types of measurement. So you see you have a module for proof certification, spot measurement, image measurement, process control, statistical reporting, connectivity to other systems like Pantone Live or Color Drive. So this is all part of our platform, meaning you can use one solution for all of these tasks. In consideration of other software, many times you have to use different applications for different tasks. Maybe you'll have one software for proof certification, a different software in your quality lab for spot measurement, and yet a different software out on your press for process control. Now this is very troubling because these different systems all need to be managed independently. It's likely that they don't all talk to the same different types of instruments, so it's a lot more of a challenge to maintain and administer a system where you have three pieces of software to use rather than one. Now, as you're doing your analysis inside MeasureColor, one of the main places that we display our data is in what we call the gamut display. The gamut display is a dashboard of everything that's going on at one time. So you see a picture we call the solid and midtone spider chart. In this case, it shows you how both your solid and screen patches are producing or being measured compared to your targets. So our white lines and white circles are illustrations of where we want to be. Blue lines, blue dots, representations of what we're actually measuring. So very quickly we can look at this picture, see if we have proper saturation, proper dot gain patches, proper screen patch color, as well as if our colors are experiencing any kind of color change or hue shift. As I look to the right of the solid and midtone spider chart, I see my solids graph. This is easily communicating to me the performance of my colors. I see that my black is right on center line. It's perfect. My cyan, a little bit strong, magenta a little less strong, but still a little bit over our target. But yellow is about 5% too strong right now, and I need to consider what kind of effect that's having on my density, my delta E, and dot gain. Below that solid line graph, you see TVI at 20, 40, and 70. TVI is one way of representing tone value increase, and that's the representative at 20, 40, and 70% screens in those graphs. But the software does dynamically change depending upon which patches you have in your color bar. So if you're using 25s, 50s, and 75s, you'll get those graphs instead of 20, 40, 70. Below that, graphs for paper color and gray balance, very easily using the crosshair type diagram showing you where you are in comparison to where you want to be. So I can very quickly see my paper is outside of 2 delta AB down to the blue side, and my gray balance is shifting a little bit, looks like to the yellows, oranges, maybe a little bit to the purple, depending on which percentage I'm looking at. But I can see that they're all looking pretty good. They're all within that 2 AB ring. Now, as I look at the bottom of the gamut display, I see my solid patches. I get 1 block per color that's in my color bar. This is a simple 4-color process job. The software is capable of doing up to 12 colors at a time. And beneath those patches, I see my average measured delta E and whether that's a pass or fail. So very quickly, I can look at this screen and know my yellow has a problem. It's too strong. It's a 476 delta E, and that is a caution. Now let's go to another technology we have called ChromaTrack. ChromaTrack is a way that we can communicate to the operator how to adjust color to get a better color match. Now, oftentimes operators are most familiar with adjusting color densitometrically, meaning by putting more ink on or taking ink off. This can vary depending on your process. If you're an offset printer or if you're a flexo printer, that may adjust via a strength change and an addition of extender or additional pigment. But generally speaking, operators understand density better than they understand color. So in this ChromaTrack picture you see, the white dot illustrates the measurement that we've taken with our instrument. And as you can see, it's just failing now at a 502 delta E on a tolerance of 5. It's right there on that ring. Now, if I look at the bottom of my AB plot there, you see some text that says ChromaTrack optimal predicted result at a density of 139 in the magenta filter, yielding a delta E of 1.08. So this is some really great actionable information for the operator, and that they say if I take this to a density of 139, I can take that 502 delta E all the way down to 108. They can also see a visual representation of what that looks like below, where they can see the reference color on the left, sample measured color on the right, and what that 108 delta E will look like in comparison to both laying in that little square in the middle. MeasureColor Image is something that we developed to fix a breakage or breakdown in communication. A lot of times, be it print buyers or managers will want to designate certain locations in a piece of artwork for measurement that are outside of control mark areas, or maybe there's just no room on the printed work to fit control marks. Knowing where to measure inside the art is very important. If the brand wants verification for particular locations, it's important, but even more so than that, if you have one shift of operators that measures in one area and a different shift of operators that measures in a different one, well, it's going to be very hard to maintain the consistency between those two times of printing if they were measuring in different areas. So what MeasureColor Image does, it actually puts a picture of the material that the operator is printing on screen. It'll show them via these crosshairs where they're intended to measure, and then as they take their measurements, they can see what we call the localized delta E. So that's the delta E at that particular location that they've been instructed to measure, or that their print buyer wants inspection reports. So here very quickly we can see where the problems are. Looks like locations 4, 5, and 8 all have caution signs. We can see the delta E's, and then we could click on those areas to see what's specifically going on, as well as having ChromaTrack give us a recommendation of how to get back on track. Now these are 4 additional MeasureColor screens I just want to show. Don't have too much time to go through all of them today, but just wanted to show you that we have really strived to give a different type of interface for the different types of printing you may do. So if it's a simple digital print operation that you have, We have a very simple traffic light style interface to tell you, can you continue printing? Should you stop the machine, or do you need to make a significant correction? In the upper right, we have our multi-spot view that if you just want to measure spots no matter where they are, we have an answer for that. Lower left-hand corner, this is what we call flexo view. So if you operate a flexo press, we give you the opportunity to see how a collection of marks compares from the left side, center side, right side, either as few as one side up to 4, depending how wide your webs are. And then lastly, in the lower right, we have our classic ink zone display, where if you're an offset printer, you can see how all your different ink zones are performing, where ink needs to be increased, decreased, and all your other print attributes like dot gain, delta E, trapping, and so on. Now, you heard me mention about trending. So all of this data, every measurement is going to be collected, and it's available for trending. Trending shows you the date and time that the job was started, how long it ran in make ready, and then how long it ran in production. As you're comparing that length of time the job ran, you can see the density variation as well as delta E, as well as open up those little drop-down boxes to change between different types of data display for other printed attributes. So how is all this going to save time and reduce make ready? It's honestly very easy. The faster you get up to color, the less make ready time is spent and the less waste material has been expended. So if you have the most information, the most actionable information about getting up to color faster, you'll reduce your make ready time and spend less material doing it. Now, as you continue to use the instrumentation and the software, the longer you hold that accurate color, the faster that job's going to get off press, the faster you're going to be able to start the next job. And lastly, the better the color match you hold, the fewer customer complaints and rejected jobs you'll have to deal with after the fact. So there are many different types of ROIs that we could actually go through if we have more time, but it's very simple in how these tools save you money, pay for themselves very quickly. So that about rounds up the presentation. I know we might have some questions that have been collected during the presentation, so let's open the floor to Q&A. Our moderator will introduce the questions that have come in during the presentation, and if you haven't submitted your questions just yet, please feel free to do so now using the chat window that's in your presentation software.
Okay, great. Fantastic, Dan. Appreciate that presentation. It's always fascinating to me to hear about all those, especially the part about color and the color test. If you look in your chat window, Dan put it up on the screen, but we've also included the link. So if you want to link over to that online color test challenge, that will be available in that link in your chat window. So one of the questions that's come in is, will there be a recording and can you get a copy? And the answer is yes. Early next week on Monday, you'll be getting an email with a link to be able to go and view it and also download the presentation. So another question that we have here is, what is the proper way to configure my instruments?
That's a very good question. The truth is, it honestly depends. If you do not have a customer specifying what to do, then you can follow the traditional graphic arts standards, which are density status T, D50 illumination, and 2-degree observation. But the most important thing is that to meet customer expectations, you ask them, how you're going to be evaluated, if they're going to be doing their own measurement, or if they have their own methods. So it's very important to involve your customer in a dialogue, find out what the expectations are, and then act accordingly. But there's no one correct way over another. There is a standard way of status T density, D50 2-degree illumination observation, but the truth is the best or the most appropriate is what your customer wants.
Okay, great. The next question, what type of lighting should I use in my light booth? Should I use daylight, incandescent, or fluorescent?
This is another really great question that comes back to how your customer is going to evaluate it. But as far as the standard goes, at a minimum, you should have calibrated D50, the graphic arts standard illumination, which most likely the device will be using. So this is definitely one that you want to have. A lot of the light booths today have the capability of having bulbs for 2 or 3 or more different types of illumination. So as a secondary, a lot of people will choose to use a luminant that may be more similar to where their product will be evaluated. So if what you're printing is going to be, traditionally used in a home environment, you may want to use an incandescent light to see how your material will look as that encounters that type of light. If the primary environment is going to be in a supermarket under uncontrolled fluorescent lighting, then you may also want to use fluorescent cool white as a secondary lumen to see if that introduces any color variation in what you're printing. So again, it's very important to work with your print buyer, see which environment they care their product to be the most color accurate or the most color critical, and then equip your light booth accordingly.
That makes sense. Another question, is a polarization filter only used for wet ink?
Generally, it's, if you have polarizing sunglasses, it's the same kind of idea. There are some special circumstances, but generally it's to remove the sheen or the very strong reflectance that wet ink will sometimes blind the spectra with. So if you have a very high density ink and it has, it's very wet, or the substrate it's printed on doesn't absorb it quite as fast, the primary use, I would say, of the polarization filter is to cut off that blinding reflectance and give the instrument the good capability of taking a measurement, where otherwise without a polarization filter there's so much reflectance from that wet ink that it can blind the instrument and give you something that doesn't make any sense.
Okay, very good. Another question, you might have touched on this topic, but this is a person's comment here. What I've found to be a thorn in color measurement is the backing. Currently, there's no standard backing, or is there?
There are some different types of standard backing, and again, this a lot of times ties back to the customer. There are many customers that I'm aware of that will specify the backing material to be used. Some of them have even their own nomenclature for these backings. Some of them, I believe, like a UPO paper is sometimes used. Sometimes white ceramic tiles are used, and the LAB measurements of that tile must be controlled. But backing is something that you need to absolutely be considerate of when you're taking your measurement, when you have material that is light transmissive. So if the light is going to go through the material, hit the backer, and then come back up, you need to be considerate of what your backer is, because it's going to influence the color measurement that you get. So again, if you have, or if you're asked to print on a transmissive substrate or something that really doesn't absorb all the light from the instrument, what you want to do is, again, work with your customer to find out, well, what are they going to measure on, what should you measure on, and make sure you're consistent. It's very important that everybody is then using that agreed upon backing material so that no additional artificial error is introduced to the measurement process.
Okay, great. If I monitor the filter, isn't that good enough for measuring color with a densitometer?
Some people have believed this, and it's not really, and there are a couple cases why. Again, if I go back to my cyan and magenta example, I could print both those inks at that 145 density and think that I'm doing right. Problem is that I will not know if that ink was properly formulated, or if it has some kind of contamination that's picked up in the printing unit. Both of those could change the color of the ink without changing the density measurement. So that's a risk. The other risk is that the densitometer, generally speaking, are 4 filter devices, unless we got into spectral density, which is a little bit more technical than for this conversation. But a traditional densitometer is meant for cyan, magenta, yellow, and black colors. So it has filters or observation points that are specific to those colors. Now, if we try to measure a non-process color with a standard densitometer, it's not going to fit well into one of those 4 filter positions. So what happens then is, take green as a classic example. If you measure a spot green, sometimes you may come back with a cyan density measurement. Sometimes you may come back with a yellow density measurement, and you may see the density measurement changing as these 2 filters kind of flip or trade off between each other. So it's very important that we be considerate, especially when measuring color that's non-process, as to which filter we're using, and try to minimize any switching that happens, and then even consider adopting spectral density, which again is a more in-depth conversation, but there is an answer to measuring the correct appropriate density of a non-process color.
Okay, fantastic. Well, Dan, that's it for the questions. Thank you very much for a very informative presentation today.
Well, thank you very much for having me. Thanks, everybody, for joining, and I wish everyone a terrific weekend.
And that will conclude our webinar. Thank you very much.